All right, so just like 7 more, maybe 8 more problems to do. So problem 12 wants me to solve 3 to the x equals 18. My instructions say first take the logarithm of both sides. If I saw an e, I would take the ln of both sides just to make my work easier. But I don't see any e here. So to get started on number 12, I'm taking the logarithm of both sides. Done with my first step. Now I'm going to make the exponent of x into a coefficient. Done with my second step. The third step produces my answer. For checking purposes, it's so hard to enter these answers on a calculator that I started doing 2 decimal answers to do the checking. But maybe I should do 4 decimal answers because maybe that checks better than 2 decimals. Doesn't really matter. This is all I need to see on the test. Here's my answer. If I want to check, I need this down to, let me do 4 decimals. Do log of 18 divided by log of 3. My answer is about 2.6309. That's what I'm going to check. I'm going to put a 2.6309 into the exponent for x and make sure I get pretty close to 18. Because I'm not checking the answer exactly, because it's really awful to do, I could only hope for a close checking. And I'm trying to get 18. I got 17.999. That's close enough for me. I'm going to say my answer is correct. 13 is the ugly problem, or one of 2 or 3 ugly problems, maybe the ugliest. So 13, take the logarithm of both sides, take the ln of both sides if there was an e. There's not an e. So to get started on 13, I'm going to write the log of 3 to the x equals the log of 2 to the x minus 1. Done with my first step. Now I'm going to make each of the exponents into a coefficient, leaving a parenthesis on the right side. So step 2, I get x times the log of 3 equals x minus 1 times the log of 2. That's making the exponents, both exponents, into a coefficient, having a parenthesis on the right side. Do the algebra to solve for x. First clear the parentheses on the right side. So I'm going to leave the left side, x log of 3. And the algebra to solve for x, I'm going to clear the parentheses. I'm going to multiply x times log of 2 and get x times log of 2. And minus 1 times log of 2 and get either minus log of 2 or minus 1 log of 2. It doesn't matter. So that's clear the parentheses on each side. Now I'm going to subtract x log of 2 from both sides. That's the next step. So minus x log of 2. This is very specific to this individual problem. Your problem on the test will be similar, but you won't have exactly the same logarithms. But structurally, you're going to do the same sort of solving. Isolate the constant by subtracting to get the logarithms with the x's on the same side. So that's my second step. Now I'm going to factor out a common factor of x on the left side. Each term on the left side has an x in front of it. That's going to be my common factor. I'm going to write that common factor in front of a parenthesis, leaving the right side unchanged. And inside that parenthesis, the stuff that I didn't box, the log of 3 minus the log of 2, is going to go inside the parentheses. So that's done with that third bullet. Now I'm going to divide and actually have something that's my answer. I'm going to divide both sides by log of 3 minus log of 2 divided by log of 3 minus log of 2. This is my answer. Horrendous to check this. So here's my answer to 13. X equals the negative log of 2 over log of 3 minus log of 2. And now I want to create a decimal form of this. This is the hard calculator to do it on. So minus log of 2. I need to close the parentheses that it started on me, then divided by, and I need the entire denominator in a parentheses, along with each logarithm has to have its argument in a parentheses. So decimal wise, I'm going to write negative 1.7095 and check it. Specifically, I'm going to go to the original problem and see if 3 to the negative 1.7095 equals 2 to the negative 1.7095 minus 1. And I'm not going to write down the numbers, I'm just going to do it on my calculator. So 3 exponent negative 1.7095, that's the left side. Now the right side, 2 exponent parentheses negative 1.7095 minus 1. Better equal exactly the line above it, and it looks basically perfect. Look, if they match to 5 decimals, it's not going to match to all 10 decimals because I'm doing rounded answers. The more decimals I include in my checking, the better the match is going to be. But matching to 5 decimals, boy, that's good enough. I believe my answer is right. Checking this would be just awful, and I don't want to try to check that. So for 14, I'm given a logarithmic equation. I'm asked to rewrite the problem in logarithmic form. And I write the steps down, but I don't really think I need to go through the steps. It's just scratching out the log and switching. So on 14, this first step, writing it without the logarithm, I cross out the logarithm, I bring the base down, and I switch the 4 with the x. The exponential version of this is going to be 3 to the 4 equals to x. That's all this is trying to tell me to do that the best I could in words. And now I'm going to solve for x. Well, x is basically solved for. I get 81 equal to x for my answer to 14. And then I'm going to check to see if I go back to the original problem and plug 81 in for x, if I get a true statement. Easier to check on this calculator because it has the log base. So math, log base 3 of 81. Make sure that that equals to 4. Does perfectly, so I've checked. On this calculator, I would have had to do log of 81 divided by log of 3 to check. Still checks. "15 wants me to solve something that's written with an ln. ln is shorthand for log base e, and if I'm going to solve by scratching out the logarithms, I need to see that base. So in step 1, I wanted to change the ln of x to the log base e of x. They're equal to each other. The ln is shorthand, which is often better, but not for this particular problem. So that's the end of step 1. Now I'm going to do all the algebra to get the problem written without a logarithm. I'm going to cross out the logarithm. I'm going to bring down the base of the logarithm, make it the base of the exponent, switch the 2 with the x. I actually have an answer because this is already solved for x. My answer is going to be e squared equals to x. That I could check on my calculator pretty easily. In fact, let me just show you. If I just go into my calculator and change the x to e squared, I can do this without decimals. If I do ln, second and ln, and e squared, and I'll see that the left-hand side equals 2, which is the right-hand side, which is good. On this calculator, ln, second and ln, and then I type 2, close out the parentheses for the natural log, and you see that it checks perfectly. That I don't even need a decimal for. The only reason I go into decimals is because when an answer is really complicated, it's just awful to try to check, and checking the decimal is not so hard. 16 wants me to rewrite the problem in exponential form, and this whole business here is just to tell me to do this. Scratch out the logarithm, bring the base down, make it the base of the exponent, and switch the order of the x plus 1 and the 5. This is going to create the exponential function 2 to the 5th equals x plus 1. That's all what step 1 and all those bullet points is telling me to do. Scratch out the log, bring the base down, switch the x plus 1 and the 5. And now I'm going to solve this. Super easy to solve this. 2 to the 5th is 32. And then minus 1, I get x equal to 31. That's not even a decimal, and I'm going to check. I'm going to check to make sure, if I go back to the original problem, that the log base 2 of 31 plus 1 equals 5. Way easier on this calculator. Math, log base 2 of 31 plus 1. Works perfectly here. I get 5 equal to 5. And on this calculator, it's log of 31 plus 1 divided by log of 2. And you still get the checking. The left side, when you simplify it, matches up with the right side. On 17, it has two natural logs equal to each other. And in this problem, I can just drop the natural logs, set the arguments equal to each other, and do the algebra to isolate the x. Minusing 3x and adding 8 would be good algebra here. I don't have to do any setting equal to 0 because there isn't a square term. This is going to give me x equal to 7. And this I can check without my calculator. Go back to the original problem and see if the natural log of 4 times 7 minus 8 equals the natural log of 3 times 7 minus 1. This is going to give me the natural log of 28 minus 8 equals the natural log of 21 minus 1, which is the natural log of 20 equals the natural log of 20. I don't need a decimal approximation to know that those are equal to each other. So I'll just say it checks and not even pull out my calculator. 18 and 19 are the harder problems. On 18, I'm going to first use the minus to divide rule to take these two logarithms, same base, separated by a minus, to write them as one logarithm. If you have two logarithms, same base, and they're separated by a subtraction sign, you're allowed to condense those two logarithms into one logarithm if you divide their arguments. This is what step 1 wants me to do. I use the rule that tells me if I have subtraction between two logarithms, I can make it into one logarithm with a division, as long as the logarithms have the same base. And you notice I didn't use parentheses anymore. The fraction bar is working like the parentheses. Now this whole business of making this into an exponential equation, I'm going to cross out the logarithm, I'm going to bring the 2 down, and I'm going to switch. And when I do that, I'm going to get 2 to the 1 equals x plus 2 over x minus 1. That's all the end of step 2 is this. This junk, just a little bit right there, that's way longer than what it looks like. Now I'm going to solve for x. This left-hand side, it right now says 2 equals x plus 2 over x minus 1. And I'm going to need to cross multiply to solve. So I'm going to need to make the left-hand side into a fraction. So I can actually do that cross multiplying. And 2, which is the same as 2 to the first, I could make it a fraction by writing it over 1. Now I'm going to cross multiply down and cross multiply up, put the bigger coefficient on the left-hand side. That makes the math easier to follow. Cross multiplying down, you get 2 times x minus 1, which simplifies to 2x minus 2. Cross multiplying up, you get 1 times x plus 2, which simplifies to 1x plus 2. And now I'm going to minus 1x and add 2 to both sides. And this is going to give me what I believe is the answer, x equal to 4. And now I'm going to check, go back to the original problem and see if the log base 2 of There's a mistake here, I think. Oh, I wrote the problem down wrong. This minus 2, look at this. From here, I wrote x minus 1. I should have written x minus 2. So this guy right here, right here, right here, right here, right here, all those are wrong. Let me change those, not all at once. Let me just do it over. This is just getting careless. So I should have written the logarithm base 2 of x plus 2 over x minus 2 equals to 1 for my first step. Once you make a wrong first step, you're doomed. Now I'm going to write it as an exponential and write 2 to the 1 equals x plus 2 over x minus 2. This 2 I'm going to write as 2 over 1. So it's going to give me 2 over 1 equals x plus 2 over x minus 2. Cross multiply down, get 2 times x minus 2 equals to 1 times x plus 2. This gives me 2x minus 4 equals 1x plus 2 minus 1x plus 4 minus 1x plus 4. 2x minus 1x is going to give me 1x. The 4's cancel. The 1x's cancel. And 2 plus 4 equal to 6. My answer should be x equal to 6. If I tried to check the 4, it wasn't going to check. I'll show you on my cheap calculator. If I tried to check the 4 that I wrote down, if I did the log base 2 of 4 plus 2 minus the log base 2 of 4 minus 2, changing both x's to 2, 4 should I say? I even got an error. That kind of surprised. I shouldn't have got an error. Let me do this again. If I tried to check the 4 and did the log base 2 of 4 plus 2 minus the log base 2 of 4 minus 2, I get 1.58, and that doesn't equal to 1. So let me check the real thing that I should check. Should be the log base 2 of 6 plus 2 minus the log base 2 of 6 minus 2, and that should equal 1. I'm just going to check on this calculator. I hope that you guys are comfortable enough with the calculator that you own that you can do the checking. This calculator is just so much easier and faster to check. And so this gives me perfectly 1 equals to 1. One problem left, and it's the problem where we're going to get 2 answers. One will likely not check. It just feels blurry. Maybe I'm just tired and it just looks blurry and it isn't. So last problem, problem 19. First, use the plus to times rule to write the left side with 1 logarithm. So my first step on 19 is going to be to take the 2 logarithms on the left-hand side and write them as 1 logarithm. Interesting. This would be the 1 logarithm version of number 19. Done with step 1. Now I'm going to simplify the argument by doing the multiplication. And the multiplication I need to do is actually foiling. That x plus 2 times x minus 2, I need to do x times x, which is the firsts, x times minus 2, which is the outers, 2 times x, which is the inners, and 2 times minus 2 is minus 4, which is the lasts. The 2x's cancel, and when I finish step 2, I get the log base 2 of x squared minus 4 equals 5. So now I'm going to write the problem in exponential form. I cross out the logarithm, I bring the 2 down, and I switch the 5 and the x squared minus 4. And I get 2 to the 5th equals x squared minus 4. Solve for x. I'll need to set equal to 0 and solve by factoring. Could actually solve it with square rooting, but I won't. So 2 to the 5th is 32. So in my efforts to solve for x, I do my exponent, and now I'm going to set it equal to 0 by minusing 32 from both sides. This will give me 0 equals x squared minus 36. And that I should know how to factor. That's a difference of squares. You divide the exponent by 2, you square root the numbers, you get two essentially identical parentheses except one has a plus sign, the other has a minus. X squared minus 36 factors into x plus 6 times x minus 6. Once I get it factored, I set the individual factors equal to 0. The factor of x plus 6, when I set it equal to 0 and minus 6 from both sides, I get x equal to negative 6. The factor of x minus 6, when I set it equal to 0 and add 6 to both sides, I get x equal to 6. I should check both of these. If I was lazy and not wanting to check, if I didn't make a math error, my guess will be that the positive answer checks and the negative answer won't. So I'm going to check both into the original problem. So first of all, I'm going to check the negative 6 and see if the log base 2 of negative 6 plus 2 plus the log base 2 of negative 6 minus 2, see if that equals to 5. That's not going to work because these have logarithms of negatives. I'm going to get some sort of error message or an I on my calculator if it's in the I mode. And then I'll check 6, and this will work when I do the log base 2 of 6 plus 2 plus the log base 2 of 6 minus 2. That will equal 5. So again, hopefully you can check on your own technology, but for this calculator, the top one, log base 2 of negative 6 plus 2 plus the log base 2 of negative 6 minus 2. This calculator is just going to give me an error because it's a logarithm of a negative. On either one of these calculators, I'll get an I. On this calculator, if I try to do math log base 2 of negative 6 plus 2 plus math log base 2 of negative 6 minus 2, I think I have this calculator back in I mode, and it's going to say 5 plus basically 5 plus 9i equals to 5, and that doesn't equal to 5, so it doesn't check, so it doesn't belong in my answer. This one will check. Again, I'll just do it on this calculator. Do the log base 2 of 6 plus 2 plus the log base 2 of 6 minus 2, and you get perfectly that 5 equals to 5. So when I write my answer, I don't need to include the solution that doesn't check, but I can, and it would be fine if you said x equal to 6, comma, x equal to negative 6 does not check. And the nice way to say that it does not check is to use the word extraneous. Extraneous implies to somebody that reads math that the algebra produced the solution, but it's a solution that didn't check. So that's the entire chapter 6. All we have is chapter 8 left, but there's no chapter 7 in our class. I wrote the material in our class to kind of match up with the book that we use so that the chapters line up the same, just in case some students wanted to have another resource other than my lectures. I could point them to a text to help you out. Quite honestly, the text is a pretty heavy read, and most students probably wouldn't benefit from it, so that's why I don't really harp on it so much. All right, so we're just going to rock this test, and we just have the one chapter left.